Hi friends, I'm Dr. Subramaniam from Siri XRG Hyderabad. Today we will talk about water conservation, in particular to the thermal power plants. Water conservation is becoming a important subject because it is a important source. Water, particularly in thermal power plants. If you ask anybody what is your heat rate and what is your makeup water percent DM water makeup or the APC, they can able to easily tell their figures. But if you ask them what is the specific water consumption to produce 1 unit of power, so many people may not able to answer quickly because earlier they are not monitoring. Nowadays, most of the power plants, particularly NTPC, they are monitoring and they can able to tell. But in somehow still many people are not aware of what is their specific water consumption. So as per the recent norm of Ministry of Environment and Forest, thermal power plants who are old power plants, so they had to maintain a specific water consumption of 3.5 liters per kWh or 3.5 meter cube per megawatt hour. So that is the norm for the old plant. Those the plants were commissioned after 2017, January 1st, 2017. The norm earlier was they fixed 2.5. Afterwards, again, they revised it to 3. So 3.0, the 3 liters per kWh or 3 meter cube per megawatt is the norm. So to keep that norm, but if you see the actual based on our water audits in many of the thermal power plants. In fact, we take name the any NTPC. Almost we have done so far almost 30 water audits. 30 water audits almost all NTPC and also some of the state PSUs, say state public sector units. We have done water, few of them, and also in refineries, oil refineries, then cement plants, and even including railways. So we have done the water audits and also the some of the municipalities where for drinking water purpose. So these all these our experience, we can say that now the specific water consumption maintained in some of the even in ATPC plant varying from 1.6 to almost all 8 in some other places 8 liters per kWh. Again, this depends on the size of the unit, and again depends on the either it is a gas plant. So gas plant normally having a low specific water consumption because there is no ash handling. Similarly, if there is a once through system, if the once through system again there is no cooling tower, so again the specific water consumption varies. In some of the plants like NTPC Dadri, there is only dry ash handling. So there again specific water consumption is lower. So like that, there is a lot of variation is there. Still, many plants are not able to even maintain below the 3.5 level, and a lot of now awareness is created nowadays. So what we can able to help in based on our experience. So we can able to do the water audit because we have a ultrasonic flow meters. Again, we can able to monitor right from the raw water, because if you were to, because you can't able to only main specific water comes though is raw water, but by monitoring water flows and doing water balance in each and every system, like right from the raw water pump house, then comes the PTC, that is a pre-treatment pump house, then the treated water pump house, then that is the clay water, then service water, then the fire water, then the ash water. Ash water. There is a LP, LP water. Then there is HP water. Then ash slurry. Then ash slurry is again dispatched to the ash dike. So, addition to then some places there is a ash dike again. Water is recycled. Water is recycled, though there is a ash water recycling system. So, if, by doing water balance and monitoring flows and also simultaneously measuring power and pressure, we can able to assess their efficiencies and also do the any monitor, assess the leaks or the losses in each and every system. So by that, we can able to bring out what is the major water consumption, because normally people are monitoring only the DM water. So DM water consumption is hardly not even less than 1%, 1% of the makeup. So for that he hardly per hour, it comes to only the not even 60 to 100 meter cube. Whereas the raw water consumption, even if you take a typical say 2 into 600 megawatt, so using the megawatt at even at 3, so that comes to almost 4,200 meter cube. So to 4,200 meter cube per hour is the typical raw water consumption. Whereas some of the plants even may well higher. Some of the NTPC plants where there is almost 2,000 or more than 2,000 installed capacity, the hourly consumption itself more than 10,000 meter cube. So 10,000 meter cube. So based on our studies, there is a saving potential assessed in some of the plants is almost 30 to 40%. So 30 to 40% we can able to reduce the water consumption by adopting by maybe one is ZLD, that is zero discharge, and also by optimizing a COC and also optimizing ash water ratio. So apart from that, there is a lot of leaks. So leaks, particularly in the fire water system and also in the normal other lines. So we have assessed and able to reduce their given the recommendations to reduce to make it below the some places it is below 3.0 and some places below 3.5, and with that the associated auxiliary power consumption. There is associated because there is a close nexus between water and energy. So wherever there is a pumping power is reduced, the water is reduced, water consumption. So automatically the pumping power also reduced. So we have seen there is a auxiliary power connection in equivalent to almost so one of the plant, the saving was almost 3.3 crores, more than 3 crores. So we could able to save when only in though the power cost was taken only at 2 rupees 50 paise. So like that, we can able to do monitor and measure, and each location, each node we can able to measure hourly, and also we can able to make it depending on the number of operating hours, because all the pumps may not work continuously. So where we can able to do the balancing hourly basis or the daily basis. So daily basis we can see and compare if it is already some norm is there. Again, depending on the design flows, some of the pumps design, we have seen is some of the pumps even giving a more flow than this, because when there is normally 2 pumps are supposed to run, but 1 pump is run. So because of less friction, less pressure drop, there is a more flow. So this is the that has to be assessed and monitored. So these things we can able to do when you do the real audit, water audit, and each at every location, because each pipeline we can able to connect it and they can monitor, and all in the name you give the line, we can able to particularly in CW system there is no flows we have seen, and particularly whatever water going to the CT system, so the particular cooling tower, so that I can able to assess and we can see whether it is meeting the, so that we can able to see the vacuum. You can interrelate with your vacuum from the condenser, because typically our CW flows somewhere around 100 to 120 meter cube circulation flow is required. So whether it is there, sometimes we are giving more means unnecessarily is a waste of power. Though we are not wasting the water, but we will be wasting the power. So those also can be monitored. So for this, now we are able to, we have come out with even a dashboard. We can able to create a dashboard for all the flows, so that we can able to, in single system, we can able to see at each and every location what is the, if you have already flow meter, existing flow meters, or we can able to recommend additional flow meters. additional flow meters wherever required to closely monitor the water consumption and take action. So these things, either for the raw water, normally people will be there for flow meter, whereas other places, how much water is going to your coal handling plant, how much water is going to your fire water, because fire water again is misuse. So fire water, particularly people, it is freely available at a higher pressure. People tend to use it for even floor washing. So floor washing, so the typical pressure maintained is almost like 8 kg, whereas normal you can able to use even service water for that purpose. So when you use that 8 kg, the consumption will be higher and also you will be wasting power. So these are the things we have identified, and in addition to that, particularly where we are having a colony is there. So colony, normally drinking water is sent to from the main plant. So the water consumption, if you see the monitor, so we have seen the norm is almost all around 135 liters per person per day is the typical norm, whereas we have seen more than 10 times. So more than 1,000 liters per head per person is the typical lavishly people are using in colonies. So that is also one of the parameter we can able to closely monitor, and can able to reduce that consumption even at 50%, because we can't able to meet the say 135 liters. At least if we able to reduce 50%, it is a good. For that one, what is required is just reduce the number of pumping hours. Instead of running the plant for running the drinking water pumps for almost 10 to 12 hours. For the instead of that, if you reduce the working hour, automatically it will reduce. Similarly, major culprit is the ash water ratio. So ash water ratio, people are earlier, we have seen some of the plant, there is 1:22 also, we have seen 1:28 in stage 1 and 1:28 in other stage 2, like that they are maintaining. Now drastically reduced. Now the ash water ratio people are able to monitor daily, and from the laboratory they able to take samples. Now we have seen the still it is still like for some places we have seen after 22, now it has reduced to 1:12, and whereas the design is 1:8. So we can able to bring it to a design because many times now all the people are having fly ash is being sold for the cement plant. So the ash consumption, ash particularly that ash quantity, dry ash handling is more. So there is no need require the ash water ratio also reduced. So it is a 1:5 is some of the latest plants that are maintaining. So by bringing it to optimizing, because we can't do one day, we can't reduce it. Maybe slowly, because we can able to reduce in a state in a stage manner. We can able to reduce it to bring it to 1:5 or 1:8. So that itself gives a major saving. And also the similarly the power also, because the major, because series pumps, 3 series will ABC will be running. So even one or two series are running, and even by reducing the ash water ratio, automatically your pumping hours can be reduced. Hours can be reduced. That will give the major auxiliary power consumption reduction. So apart from this installation of, suppose we cannot able to reduce water consumption, many times there is a even cooling tower. So cooling tower, there are two options are available. One is we have seen many places the basin leaks are there, and also sometimes basin overflows because of makeup. There is a overflow in that, again that water sometimes it is recycled, or it is just going to drains, and the drains are connected to the storm water, and it is going out of the boundary. And this is a another thing is where we have seen the drift losses. So drift losses, sometimes if you go near to the cooling tower, you feel that there is a, it is as if it is a raining. It is a raining, and also that place is almost all like water logging is there, and algae growth and all. So because many people don't go near to the cooling tower, and this is another neglected area. So for this again, by monitoring water consumption in the cooling tower, whether it is per megawatt, it is 100, what I told earlier, 100 to 120 meter cube is sufficient for circulation. But many times it is more, because whether it is a unit is running at full load or even at part load, but same number of CW pumps will be running. So that is circulation rate is more. So this one area to not only conserve water and also the auxiliary power consumption. So we, by this, with our experience, we can able to help you to bring it to the below the norm and also implement the what I told, the dashboard. So dashboard, wherever already you have a flow meters and also energy meters, we can able to calculate the specific water consumption. Specific water consumption not only for the total plant, even for the individual pump house. Individual pump house we can able to calculate, and depending on the existing flow meters and also energy meters, and we can able to even give the efficiency of the pumps, so that we can able to see the intercomparison pumps efficiency, and take corrective action, whether to take it for the maintenance, or we can able to stop one pump and run the standby pumps. So this is dashboard, definitely we can able to give the online, so that once we able to measure, we can able to even monitor. So this is the services we can able to offer. And if you are require anything, we can able to contact us. And our experience is, we almost all, with, as I said, the 30 power plants we did all so far. So 30 power plants that we can able to reduce almost 30 to 40% the same showed, and also simultaneous auxiliary power consumption. And thank you. And we can able to contact us, SiriXRG, and our email is siriXRG@gmail.com, or you can contact us my WhatsApp or my mobile number. You can able to see from the net our details, and hope you will be able to utilize our services. Thank you.